Hello mathematicians, and thank you for joining me. Today what we're going to be doing is a little bit of proofing and a little bit of calculus work. And so what we're going to do is we're going to look at limits, and we're going to say, can I show that the limit as x goes to 2 of 3x minus 5 is indeed equal to 1? And we want to do this from a more formal way than we would normally do this in calculus. So that is, what we need to do is we actually need to come up with what would the definition of a limit be. And so the idea of a limit is that what happens is x is getting close to 2, my function value is getting close to something, and so if I actually graph this function, what I get is 3x minus 5 is going to look something like this, approximately, and then what I want to know is what happens as x gets close to 2, what happens to the function values. So now a little bit more formally what we have to say is, well, what does it mean to get close to? Is close to off by 1 or off by a half? And that kind of depends on the situation you're given. And so what we need to do is we need to be able to say that it gets as close as we want it to be. So the idea here is that if you give me any number, I can say that based on the number you give me, I can keep the function values within that range of the limit for some values of x. So, normally what we say is you would say that you give me an epsilon. I don't know what epsilon is, but I'm going to put it up here as that's my epsilon. Since my limit is 1, or I claim my limit is 1, what I have to be able to do is draw a line epsilon above 1 and an epsilon below 1. Now, once you've given that to me, the point is that I can pick a delta where I have to stay that close to 2. So let's say I pick my delta to be this value here. And in that value, I would draw these vertical lines. And what I have to be able to do is choose this delta so that the function values stay within the white lines. So the horizontal lines, I can't cross those with my yellow line whenever my yellow line stays within the blue lines. And so you'll notice here that the smallest my yellow line gets here is still above the white line and below this white line. This one again is above this white line and below this white line. So on that given delta interval, all of my y values stay within epsilon of my limit. So what we want to do next is take that idea and we want to turn it into a formal definition. And what we're going to say is that, well, the limit as, in general, x goes to c of f of x is equal to L, if for any number that you give me, so any of these that you give me, that is any epsilon which is positive. So you can make it as small as you like, but any positive number you give me. So if for any epsilon greater than 0, I can find, or that is there exists, a delta greater than 0 such that as long as I stay within delta of my x value or my c value, all my y values are going to stay within epsilon of my limit value. That is f of x minus L is less than epsilon whenever x minus c is less than delta. Now, the one stipulation I did leave out about a limit is that because I'm taking a limit, I don't actually care what happens at this value right at 2 or right at c. So what I have to do is I have to account for that as well. So I'm going to say whenever 0 is strictly less than x minus c is less than delta, so that it's for all the x values that are close, but not necessarily equal to the c value. And so if I want to show that the limit as x goes to 2 at 3x minus 5 is equal to 1, I have to show that for any epsilon you would give me, I can find a delta such that f of x minus L is less than epsilon whenever my x minus c's are less than delta. Alright, so in order to get through this proof, what we need to do is we need to figure out, based on your epsilon, what should my delta be. And so what I want to start off doing is just look at what is f of x minus L equal to. Can I simplify this? Can I get this out so that I can use something about delta to get that this has to be small? So now if I look at f of x, that's the function inside the limit. So here I'm going to get 3x minus 5. And if I take the limit, it's just this number over here. So I'm going to subtract 1, and what I'm left with is the absolute value of 3x minus 5 minus 1. Therefore, I can simplify this into 3x minus 6. I can factor out a 3, and I get 3 times x minus 2. And now for absolute values of products, I can take the absolute value of 3 times the absolute value of x minus 2. So I get 3 times the absolute value of x minus 2. Now what I want to point out is that once I get this simplified, the idea is that you're going to give me an epsilon. I need to pick a delta based on your epsilon. What I need is that in the end, I need this to be less than epsilon. But what I get to pick is I get to pick delta so that I'm within delta of x, that is 0 is less than x minus 2 is less than delta. So now if I'm looking at this, what I get is that, well, 3 times x minus 2 I can assume is less than 3 times delta. And since I have a less than here, all I need is that if this is equal to epsilon, then I get f of x minus L is equal to this is strictly less than this, which is equal to this. Therefore, by transitivity, f of x minus L is less than epsilon. And what I need to do is I need to choose my delta so that 3 delta would be equal to epsilon. So what I would do is just pick delta to be epsilon over 3. So now if you're going to tell me stay within 1, I'm going to say, well, stay within 1/3 of 2. If you're going to tell me stay within 0.5 of 1, I'm going to say stay within 0.5 divided by 3. I don't actually even care what that is. I'm just going to say divide by 3. That's what I'm going to pick my delta to be. And as long as I stay within that far of x minus 2, I am guaranteed that f of x minus L will be within epsilon or smaller than epsilon. Alright, so now for my formal proof, what I can do is, instead of rewriting all this, what I can say is, okay, well, the idea is that my proof that this is true is be proof. Let epsilon greater than 0 be given. What we would say is choose delta to be equal to epsilon over 3. Then we have f of x minus L is equal to, and we would actually show these calculations in our proof, is less than 3 delta is equal to epsilon. Hence, we have exactly what we're looking for. F of x minus L is less than epsilon if x minus 2 is less than delta. Hence, we have shown that the limit as x goes to 2 of 3x minus 5 is indeed equal to 1 by the definitions of limits. Thank you for joining me today as we work through some proofs. I hope you learned something, that this helped you with your studying. If it did, make sure to hit that like button and to subscribe to the channel.